What's up, young mathematicians? Thank you for stopping by here at tautwopi. I am Caesar the tutor, and today we're going to be going over the properties of the real numbers. The properties of the real numbers are closure, the commutative property, the associative property, the identities, the inverse properties, and finally the distributive property. Now, a lot of these things you already know. You already know them. And if you're starting in algebra, remember that the goal of algebra is to start building math from the bottom up. So you learned what the sets of real numbers were. You learned that the sets of natural numbers is the first one we always know. And then we start extending that set into a bigger set until we arrive at the real numbers. And the properties that you're going to see today are simply tools that allow you to manipulate the numbers in the real numbers. And so remember, if you have a bicycle, a skateboard, or a car, you kind of already know what tools are. If you're trying to fasten a bolt, you're not going to use a screwdriver, okay? You're probably going to use a wrench. If you're trying to cut paper, you're not going to use a hammer. You already know that there are certain tools that you use for certain jobs. So in today's video, what we're going to do is we're just going to define those properties just to let you know that you can use them, but you've already been using them since first grade. So let's take a look at what they look like. Let's start with the definition. Let A, B, C be in the set of real numbers. This just means let A, B, and C be any numbers that are in the set of real numbers. 1, 2, 3, a negative, a positive, a fraction. Now, the majority of these properties come in two flavors, addition and multiplication. And we're going to see them in both, and we're also going to use actual examples with numbers so that you can see what they mean. The first one is closure. And closure simply means you can add any two numbers in the real numbers and always get a real number back. So we say that the real numbers are closed under addition. For multiplication, same thing. You can take any two numbers in the real numbers, multiply them together, and get a real number. That is all closure means, that whenever you add two real numbers or multiply two real numbers, you're going to get a real number back. Let's say A equals 5 and B equals 6. We add them, we get 11. Here, well, let's say A still equals 5, but let's say C equals 10. So 5 times 10 is going to give us 50, which is also a real number. The next property that we're going to go over is going to be the commutative property. And the commutative property states that if I'm adding two numbers, I can simply add them in any order. So A plus B equals B plus A, which you already know because you know that 5 plus 3 equals 3 plus 5. We know that already. For multiplication, same thing. When you study your timetables, you discover this pretty early. 5 times 3 is exactly the same thing as 3 times 5, which is 15. So the commutative property of multiplication tells you that you can switch the order, or the commutative property of addition tells you that you can switch the order. The next property that we're going to go over is going to be the associative property. And the associative property for addition tells you that you can switch the order that you're adding. So you can add A plus B first and then add C, or you can add B and C first and then add A. So as an example, we can have 3 plus 2 plus 5 equals 3 plus 2 plus 5. The only thing I'm doing is switching the order that I'm adding. I'm going to add these two first, and I get 5 plus 5 equals 10. Now I'm going to add these two first, which I get 7 plus 3 equals 10. The associative property for multiplication says the same thing. All you have to do is, if you have 5 times 2 times 3, it means exactly the same thing as 5 times 2 times 3. And if you multiply them, 5 times 2 is 10 times 3 is 30. 5, well, we're going to leave this alone. 2 times 3 is 6. 6 times 5 is 30. And we get the exact same thing. Now, the identity properties are something that you also already know. The identity property of addition simply states that there is some number that when you add any number to it, you're always going to get the same thing. In math, we write it like this. Some number plus some number has to equal the same thing. And we already know what that number is. That number is 0. So the identity property of addition simply says that there is a 0 and that whenever you add anything to it, we end up getting the same thing. 5 plus 0 equals 5. For multiplication, it's not the same number. Think about the fact that for multiplication, the identity has to be that whenever I multiply A by some number, I have to end up getting the same thing. And we all know that number is 1. So this is the rule that simply tells you that multiplying by 1 gives you the exact same thing. And like I said, you've already known this since you've been learning your times tables. So 5 times 1 equals 5. 100 times 1 equals 100. X times 1 simply is going to equal to x. So anything that you multiply by 1 is going to give you the exact same thing. That's what the identity property of multiplication is telling you. The inverse properties of addition and multiplication are very important because they establish two operations that you already know but did not know. So let's take a look. The identity property of addition says that for every number in R, so for every real number, so for now we're going to say A, for every real number, there is another number that when I add these two together, I get 0. And what it's saying is that we usually going to call this number negative, whatever this is. This is the same thing as subtraction, but in addition form. And so now you can see where subtraction comes from. It comes from the fact that every real number has an opposite number to it. And we call these opposite numbers or negative numbers. If you know that there's a 10, you know for a fact that there exists some number negative 10, that when you add those two together, you're going to get 0. On the other side over here, there exists a multiplicative inverse of x, or of a. For every real number a, there exists some number that whenever I multiply it by it, I end up getting 1. Okay, that is the inverse property of multiplication. And we call this number the multiplicative inverse, or the reciprocal. So we already know that the reciprocal of this is 1 over a. And this is letting you know that if you multiply a times its reciprocal, you're going to get 1. The only number this does not work for is when a equals 0. So I cannot do this thing with 0. 0 times 1 over 0 doesn't make any sense. In fact, this property lets you know that 0 does not have a multiplicative inverse. 0 does not have a reciprocal. That is why we can never divide by 0. And so if we look at an example, we can say that if a is 5, we can multiply it by 1 over 5, and we know for sure we're going to get 1 because this rule is telling me. If they're telling me that a is 2/3, then if I multiply it by the reciprocal, and we know that the reciprocal of 2/3 is simply 3/2, we are for sure going to get 1. And this is going to be very important. And guess what we just did? Multiplying by a fraction is the same thing as dividing. And we're going to go over what that means in further videos. The last property is going to combine both addition and multiplication. And we're going to come up with something called the distributive property of multiplication over addition. By the way, nobody ever calls it that. Everybody just calls it the distributive property. If you have some number and you're multiplying it by two numbers that you're adding, it's exactly the same thing as if you were to multiply this number by this one first and then add it to this number times that number. And how does that work? Visually, you can think of it like this. Since you have to multiply this times these two, it's exactly the same thing to say a times b right here. So I'm going to take that a times b and put it over here. Now I'm going to say a times c, and I'm going to take that c and put it at a times c over here. And I know there's a plus sign in between, and I end up with that. And they're letting you know that this is exactly the same thing as if this a was on that side. You're going to end up with exactly the same thing. As an example of just so you can visualize it, think of this equation. We already know what this is. 2 plus 5 equals 7. 7 times 3 is 21. We know we're supposed to get 21 back. But let's try this method to ensure that it works. First, we're going to multiply 3 times 2. And we're going to get 6. So I'm going to put that here, 6. Then I'm going to do 3 times 5. So 3 times 5, and I get 15. And there's a plus sign in between, so I'm going to put a plus. And we know that 6 plus 15 equals 21, so the distributive property holds. So let's do a recap real quick about what all these mean. For any numbers, so for any A, B, C in R, so for any numbers in the real numbers, closure just simply means that whenever you add two numbers, you're going to get another real number back. And whenever you multiply two real numbers, you're going to get another real number back. So that's closure under addition and closure under multiplication. The commutative property simply states that you can add numbers in any order or multiply numbers in any order. So remember, 5 plus 2 is 7, 2 plus 5 is 7. 10 times 5 is 50. 5 times 10 is 50. The associative property tells you that you can group numbers when you're adding. Let's say you're adding 4 numbers or 3 numbers. You can add them in any order and still not change the value of the final sum. The same thing with multiplication. If you're only multiplying numbers, you can multiply them in any order and you're not going to change the value of the product. The identity property is simply letting you know that multiplying by 1 gives you the same thing and that adding 0 gives you the same thing. The inverse properties, they let you know that for every real number, it's negative. That when you add them together, you're going to get a 0. And for multiplication, it's just letting you know that the reciprocal exists. When you take the reciprocal of a number and you multiply it with the number, you're going to end up getting 1. And remember that the only number that doesn't have a reciprocal is 0. And the only number we cannot divide by is 0. And then the last one is the distributive property, which is the one that kind of doesn't make much sense to us in our minds. But just know that if you have a box of donuts and you have a group of kids, you're going to distribute equally to all of them as much as you can. So you're not just going to take the box and give it to the first kid that shows up. You're going to be like, okay, you get one, and everybody gets one. So that is all for today's lesson. Thank you for stopping by. If you like the video, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, make sure to put them in the comments below. Thank you.